Lately, I've been hearing a lot that Rust is this amazing new programming language, the one that supposedly solves every problem in the industry with a single stroke. Well, let's put that to the test. Imagine a document model made of nodes. We'll create a base type, DOM node. In our document, there are cards, each with text, images, arrows, and buttons placed on them. So we'll need a base type for card elements, card item, and for simplicity, let's define one concrete class, text item. Our task is simple. Create a pointer to a DOM node that actually refers to a text item, then cast it to a card item and call a method on it. Easy. Well, not quite. This little demo shows how typecasting works between a base class, an interface, and a nested interface. And here's the catch. There aren't many compiled, high-performance languages that guarantee memory safety. Rust is one of them, so let's compare. Let's try to implement this task in the Argentum programming language. Although it is not necessary to have a basic DOM node interface, Argentum has a system object base class for everything. But for clarity, let's create a basic interface called DOM node. Since our application has documents with nested cards, and these cards have nested polymorphic card items such as texts, images, buttons, etc., let's create a base interface for all card items. The card item interface extends DOM node and adds another method. Let it be just the echo method. For the sake of this demo, let's create one class called test item that implements the card item interface. The implementation of the card item interface has an echo method that simply prints text to the console. That's it. We can start using this hierarchy right away. First, let's create an instance of the test item class and store it in a variable. But first, let's cast this instance to the DOM node interface. Why? So now our text as a DOM node variable has the type pointer to DOM node, and it points to the newly created instance of the test item class. Let's use it. First of all, it's a DOM node, and in order to call the echo method, we need to cast this DOM node to a card item. It's as simple as that. Look at this example. Here we have an upcast, and it has 100% success. That's why the result of this cast is just a pointer to another base type, base interface, or base class. But here we have a downcast. Not every DOM node is a card item. That's why this task is performed with runtime checks, and we need to check the result of these checks because it is returned as an optional value. We need to unwrap this optional value by checking for null and call the echo method only if this check is successful. Let's try running this application. Error, unresolved name. We have to import the log function from the system module. Let's run it again. Success. That's it. 16 lines of code, very clear and straightforward. Let's implement the same functionality in Rust. First of all, we need RC and refcell smart pointers and a cell object that allows mutable state inside immutable objects. Combinations of RC and refcell give us shared pointers to mutable objects. They are not built into the language, so we have to import them from the standard library. Let's define a base interface for all DOM nodes. So far, it will be an empty interface without any implementation. By the way, interfaces in Rust are called traits. Also, we need a card item interface, as in the Argentum case, and we declare that a card item extends DOM node and define a method equal in that interface. So far, everything is similar to Argentum. Let's go on and define a structured text item that will implement our card item interface. With implementation, much like the previous Argentum example. Next, we need to implement a new method that simplifies the construction of new text item instances. It is not strictly necessary so far, but let's do it. Here we create a self-type text item, and we create it inside a ref cell, because RC requires everything inside to be immutable, and since our objects have to be mutable, we have to nest ref cell into RC. So we create three entities here, the structure text item and RC nested inside one another. Our entry point function main, we create a new text item using our newly defined new function. As in Argentum, we cast this return value RC ref cell self to RC ref cell den DOM node. This dyn is a special keyword that makes this pointer a fat pointer. It actually consists of two pointers, one to the data structure and one to the interface method table. This is the way of polymorphism in Rust. So far, everything is much similar to the Argentum example, a little more wordy, but with no big difference. The problem is that we can cast a card item to a DOM node because we declared it as such. A card item is a subtype of a DOM node. That's why this cast works. It's an upcast. Unfortunately, Rust has no way to downcast pointers to another interface. We need to implement this functionality manually. Let's do it. Our DOM node gets another method, asCardItem. It returns an optional value containing our RC_refCell_DIN_cardItem. For every DOM node, it returns option none. But for actual nodes that can be cast to a card item, we implement our own cast logic. We have to repeat it in every real type that implements the card item interface. The question is, how can we return RC_refCell_self if all we have is just a reference to the inner structure nested inside all those wrappers? There is no easy way. We have to store, in every object, a reference to the outer RC and refCell wrappers, and since we must prevent memory leaks, it should be a weak pointer. Now let's add a field in text item and repeat this field in every implementation of card item. It will be a weak pointer to refCell text item. We declared this field, which means that we have to initialize it every time we create a new object. We cannot initialize it right away when we create the structure because it is nested inside a refCell, which is nested inside an RC, and the weak pointer is a reference to that RC. So first, we initialize it with an empty weak pointer, then store this node, then take it with borrowMute and assign to its field a reference to the outer RC container via RC downgrade. After that, we return this node as the result of the new operation. With this newly declared and initialized field, we can finalize our cast operation. We take the weak pointer, upgrade it back to RC, check for null, and if it is not null, we cast it to the card item interface. That's how we perform a downcast from one interface to another. In our main function, we take this pointer to the DOM node interface. All this boilerplate with borrow and borrowMute, we just have to get used to it. We call the asCardItem method that we just defined. It returns an optional value. As in Argentum, we have to check this option and call a method only if it is not empty. So if the cast succeeds, unlike Argentum where it is a single lee, here it requires a larger syntax. We have to make an if-let pattern match expression that takes the result of asCardItem and matches it to some value. We connect the inner wrapped RC pointer to a local variable, and only if it matches do we execute everything inside that if block. We grab the inner structure in an immutable manner and call the equal method, which is immutable because it doesn't borrow self-mutably. After that, our code basically works and produces the same output as our Argentum example. Let's compare. This code is 3 times longer and very painful to write with all this syntax. Borrow, borrowMute, upgrade, downgrade, pattern match, unwrap, map, etc. over and over again. Everything that in other languages would take just a few symbols or implicit conversions, in Rust turns into verbose code. To make a simple typecast between two interfaces, you have to create invisible fields, add methods. So what do we see? Rust is verbose. A simple program turns into 3 times more code than it should be. It's heavy, unforgiving, and forces you to manually implement things that other languages handle automatically. You must constantly manage ownerships and borrows, mutable, immutable, pointer as object, and object as pointer, all separately. And often, the bookkeeping is more complex than the actual task. Rust's type system demands that even simple operations like the one above require you to add fields, write boilerplate constructors, and define manual type conversions. It's long, hard, expensive, and painful. And the funniest part? By adding an asCardItem method to the DOM node interface, we broke type system transparency. Now, a higher level interface knows about lower level ones. Will I use Rust in the future? If I'm paid to, sure. I know how it works under the hood and how to avoid its monstrous pitfalls. But if I'm choosing for myself, definitely not. For system level work, C is enough. For application level programming, the real backbone of modern software, I'll stick with something truly safe, compact, and friendly with proven memory leak immunity.